To continue our conversation, I'll go ahead and start by sharing my screen. So behind me, you'll see my screen. I'll hide in the corner over here, and I'll even go ahead and double share my screen so that you can see the fonts and the text as clearly as possible. Now, for our open data and results section, we're going to begin by talking about how we can write a data management plan. For those who are unfamiliar, a data management plan is an ever-growing common component of grant proposals that you are going to need to write. And specifically, your data management plans are there to address the what, when, where, how, and the who, all revolving around the data that you are going to either use, preserve, or share with a given project. So when we talk about the what, well, we're often going to be talking about the digital files that you're going to create, because most data that exists nowadays is no longer going to be bound to a physical page. It's instead going to be held on a computer. And this is the way that we want to do things, because this is going to be the easiest way that we can also share and access this data. But not all file types are created the same. We typically will disseminate between two different types of files: those that are text-based and those that are binary-based. Now on the screen you see an example of a number of different files. I have a CSV file, Parquet, JSON, HDF, NetCDF, ISA, and FITS. And while there are a lot of different file types that you can choose from to store data, well, they are not all going to be equally weighted or equally important. For example, both the CSV and the Parquet files are going to be used to hold on to tabular data, that is data with rows and columns, whereas the JSON file type is going to be used to hold on to typically nested or node-based data. You could also use it to represent tabular data as well, but you'll notice that it's going to have a looser structuring than either the CSV or the Parquet. And in fact, if we come over here to my terminal, if I were to create a quick CSV file, it would look something like this. We'd have column 1, column 2, column 3, and we would have the values. So maybe A, B, and C for the first row. We'll have D, E, and F for the second row, so on and so forth. And visually, you can see that column 1 pairs with A and B, column 2 pairs with B and E, and column 3 pairs with C and F. The main thing that we're looking at here is these values are separated on a comma, hence the term CSV. Now, the nice thing about this type of file format is you can store tabular data and it is all text-based, meaning you can open up a CSV file in Notepad++ on your Windows computer, the default text editor on your Mac computer, or even Microsoft Excel can import CSV files and then you can use it as a tabular data interface there. With that said, on the contrary, we will also have what we call binary-based files. And these binary-based files are going to be files that do not represent as human-readable text. I mean, you cannot open up these files in any plain old text editor. In fact, these files, you'll typically need specialized tools for writing and reading each of these files. So the Parquet file format, it's already gotten a little bit behind the CSV format in terms of accessibility. That said, the reason that these binary-based file formats exist is that they can store much more data in a much smaller volume of space on your computer. And so while you lose some of the accessibility by using something like Parquet, you gain a lot of, one, compression, so meaning you have a reduced memory footprint on your computer when you use them, and two, you'll typically gain speed when reading these files. Now, typically, my guidance is this. CSV files, despite having an inflated memory footprint, they have a lot of accessibility and interoperability that is inherent to them. So if you have fairly small data, and small data in this sense could be thousands of rows, it could even be tens of thousands of rows that you can use as, you can put into a CSV file. Now, the one tricky thing is to make sure that you are encoding the columns correctly when you read those files in. But aside from that, you can store small data sets in a CSV file, and your life and the people who use this data file, they will be fairly happy. Now, for the Parquet file, if you have large data sets, then I would opt for something that's more binary based. So I would use a Parquet file if I have something on the magnitude of hundreds of thousands to millions of rows, then you might want to reach for a Parquet file because the CSV file is going to be impractical to use at that scale. With that said, that's our tabular data discussion. For all other versions of data, there are typically going to exist this duality. We have our JSON data structure, which is going to simply be relationships of parents, typically relationships of parent to child, but it's really any JSON array. If you're not familiar with JavaScript, because JSON does stand for JavaScript Object Notation, it practically is the same exact thing for Python lists and dictionaries. Or I'll say for R, this is going to be similar to an array of R lists here. But you'll see that I can create rows in my JSON file. So there's a JSON data structure. The value A pairs with the column A pairs with the value 1, the column B pairs with the value 2, and the column C pairs with the value 3 for this very first row. Then if I want to make a second row here, and we'll have the column A pair with the value 4, column B pair with the value 5, and C pair with 6. In this JSON file that I have just created by hand, you can see that there is one column containing the numeric values of values 1 and 4, and there's going to be the column name here that's repeated, which is A in this case. So you can use it to store tabular data, but you can also use it to store non-tabular data. In this case, the value A is going to then pair with another dictionary in this case. So A will pair with, let's say, A is just going to pair with B and C. And now in this case, there is a nesting in my data. Here, I have the value A pointing to yet another underlying object. And so this is where you can create more complex or more loosely structured data than our tabular component would let us do. Now, to address the question that just came up, yes, in Python as well as JavaScript, this is the dictionary type here. Typically in JavaScript, it could be either a dictionary, a proper dictionary, or an object, but you're absolutely right. In Python, this is a dictionary. The key here of A, B, and C are all strings. The values for B and C are integers, and then the value for A is the dictionary itself. So that is what our JSON data structure will, or our JSON files will end up looking like. For the rest of these file formats, HDF, NetCDF, ISA, and FITS, the guidance is this. If you have never heard of these in your discipline, you probably don't need to know them. A lot of these file formats will end up being very tailored to specific types of data sets or to specific academic disciplines. And so, for example, NetCDF, if you're not doing anything with four-dimensional data structures where you have like a time component over against a latitude and longitude and other elements, well then NetCDF won't make much sense for you to use. So do be aware that some of these are domain specific, whereas things that we just talked about, CSV, Parquet, JSON, they're typically used across all domains, all disciplines because they are such generalist file formats. So what else should we consider aside from what file types will my data live in? Well, you should also think about when you're planning to share some data. And so we talk about sharing at a couple of different stages. We have advanced sharing, we have intermediate sharing, we have minimum sharing, and we have no sharing at all. Advanced sharing means you have set up some type of plan to share data as soon as you can collect it. Typically, you'll have some allowance of what's called an embargo period here, where if you have a plan to share data and you want to do it very quickly before you publish whatever analysis or experiment you're conducting, well, you can still allow yourself a period of a couple months, all the way up to, I've seen embargo periods up to like 2 years or so. And you can use that time to run quality checks, to make sure your instruments are calibrated, etc., to make sure that the data is of quality before you just go ahead and share it and other people start using it. Also, of course, there is also intermediate sharing. Intermediate sharing is what I would hope that most of us already do if we aren't. Intermediate sharing just means that you share the data that you've collected at the time of publication, and typically you will release that data coinciding with the publication. Many journals will actually allow you to share the data alongside your publication. You can simply upload it alongside your publication. They'll actually share that for you. However, in the event that you are applying or publishing with a journal that does not support this type of feature, then you can always use a service like we'll see later called Zenodo or similar services in order to share that data alongside a publication. The next option is our minimum sharing. Minimum sharing just means that you have no real plan to share your data until your grant is over. Typically, I would advise against this form of sharing, and the only reason for, or the primary reason for that is going to be that if you have a multi-year award, well, holding on to multiple data sets for a long time, things can get lost, things get either confusing or disorganized. And so minimum sharing can end badly unless you are a very organized individual. So that's our minimum sharing plan. And then of course, an option is no sharing. And some of the reasons that you might not share the data that you collect, well, maybe you work on a top secret government research facility project and you want to put out a publication that's tangential to what you're doing, but you cannot share any of the underlying data that you have collected or that went into this publication due to either trade secrets or government restrictions or state restrictions, things of that nature. So while we are here to talk about open science, you should also be aware that there are valid reasons to not share everything. Within the context of being open, we want to share as much as we should. And assessing what that should component is will often require some thinking on your part about what the factors at play are, and perhaps even a discussion between you and some governing legal body that sits on top of your research team, usually like either an IRB or maybe some legal advisor or a librarian if you're working at a university. Our data management plans will also consist of where are these files going to live? Because if you tell me you're going to store your data across 20 Parquet files, that is fantastic. And you tell me you're going to share those Parquet files as soon as possible. But then when you tell me you're planning to actually put them online, you're going to put them on your private Google Drive and give nobody the link. Well, you haven't really shared anything. And so it's important to know what your options are when you are going to share something. So for many instances, we will share data in what we call generalist repositories. These are going to be repositories that are not designed for a specific community, and they are accessible to everyone. One of the most popular choices for this is Zenodo, but there are a number. There's more than 4, there's more than 20, there's probably more than 50 different options that you can choose to upload your data and receive a DOI in return. And so let's take a look at what this workflow or what this process will look like. I'm going to sign into there's Zenodo.org, but do note, like I said earlier, if you upload a data set to Zenodo.org, it will be nearly impossible to take down. So for demonstration purposes only, I will be going to sandbox.zenodo.org, which is the same exact websites, both sponsored by the same exact backend, but this is just an instance used for testing purposes. So I can go through the entire workflow of uploading a document, but I do not have to actually create any permanent record, especially since we are just seeing this here. So I'll go ahead and I will log in. I think I'm signed in with my GitHub already, so we'll do just that. And you can see I'm already signed in here. I will go ahead and share the Zenodo websites in the chat so that you all will also have access to it there. And to create a new repository, I can simply click on this plus button up here and I can select New Upload. Now, what's great about these generalist repositories, I can either upload a data set or I can even upload a software. So if I wanted to upload, say, a software, since I have one very handy here, well, I can grab all of these files here, I can zip them up, and then I can put this onto a Zenodo repository here. And so let's see if we can do just that here. I'll grab this. And yeah, let's see if this will work. That looks good. And so now I can go ahead and start creating my upload. And all I did, just so you're familiar, if we take a look at this file I just created, I'll create this. There is on my desktop a zip folder called .counter.zip, and that's going to be the file that we upload here. So I'll go ahead and grab that. We're going to go back to our Zenodo tab, and we're going to upload the snapshot of our .counter folder. And so there is my .counter zip file that has been uploaded. It's going to then ask me, just like many of these other web forms that we filled out, a series of questions about this. So do we have an existing digital object identifier? The answer for this is no, I do not have one. So I do need Zenodo to get one for me. I can click get a DOI now and it will generate that for me right then and there. So I can start adding this to other places that need it. So perhaps I can even go back to my GitHub repository that I added in. I can open up that citation.cff and I can add a DOI here just like this. And now this would be a brand new commit. I would push that on up and my life would continue. So from that perspective, or from that point on, we can then select our resource type. Is this going to be a data set that I'm uploading? Well, in this case, it's going to be a software that I'm uploading. So I'll come down here and click software. Then I will add the title. In this case, it'll be dot counter. We'll have the publication date, which will be today. And of course, we can add creators. I'll go ahead and add myself. The one thing that I really do like here is that you have the ability to search through valid ORCID IDs here. So I'll go ahead and add my own search or my own profile through the search engine here. And you can select a role. In this case, the role that I had was the project manager. We'll even say project leader. So I'll go ahead and save that as an individual on this particular project, just like this. And now we can close out and you can see I've been added as a creator. I'll add a description, and I'll add some other relevant metadata, copyrights. We'll also add a license here. In this case, it's very important that you make sure that the license is reflective of the license that you have in your actual work. And so I can either remove this license or I can simply edit this license to go and select that MIT license that I had previously. And so that is right here. So I'll go ahead and change that license on this upload. We can add any other contributors, any keywords, languages, so on and so forth. Now, once I am happy filling out all of these fields of metadata, well, we'll actually add this in here since we do have a GitHub repository at this point, and we will add a programming language there. And we are feeling pretty good about our upload here. So once we are happy with all of the metadata that we can fill out here, we'll of course click publish, and we will publish this record. This will create a record on Zenodo where that if you provide the DOI that was given to you, you will then give access to anyone to access all of these files within the zip file here. And so this is how you can get started with Zenodo. It's very simple, it's very intuitive, and it creates a long-lasting link for you to go back and revisit any data set or software that you create. In fact, I love using this because for publications, if you want to link to a very specific version of a software or a specific version of a data set, then you'll know that these DOIs don't expire, that these digital objects will stay around in perpetuity. And so that's how you can get started with Zenodo. Like I said, I made that upload on the Sandbox Zenodo website, which is great just for testing, but just know that the DOI doesn't actually work here. So if I were actually to paste this DOI in and go to doi.org, you would get a not found error. And that's just because I did this on the Sandbox version of the website and not the real website. So when we talk about where we are going to be putting things on, or putting data sets or software, the Zenodo is an option, but you can of course use Mendeley Data, Figshare, Dryad, Harvard Dataverse. There's so many to choose from. Now, a very important question just came up, and I love that this question was asked. Can I update something after I upload it? And the answer is yes. When you update an entry on Zenodo and on many of these other services here, you'll see that I have the option to edit, or specifically, let me apologize, I have the option to create a new version. And so with this new version, I can actually upload a brand new digital object. It should, of course, be semantically related to the previous one, but I can create a brand new version. This will do two things. One, you will generate a new DOI. The new DOI that you get will point to this specific version of the dataset or of the software that you have uploaded. At the same time, you will also have what's referred to as a concept DOI. That DOI will simply refer to the latest version of that dataset. So if you are citing a specific version, you should use that version DOI. If you simply want to cite the latest version of a dataset or software, you should use the concept DOI. They both look very similar to one another, but typically when you get to the record page that you see here, you can use this DOI for the version DOI, and you can use this DOI for the concept DOI. And typically they will be different in most cases. For this case, since there's only a single version, there is going to be no difference between the concept or the cite all versions or the first version DOI in this case. But they will start to, or I should say they are different in this case. So you can see that this ends in 294665 and this ends in 294664. So these are the two different DOIs here. So if you want to upload another version, you'll get a third DOI that you can choose. So if you want to cite version 2 specifically, version 1 specifically, or just the latest specifically, you can use the information on the right-hand side after you generate your upload. But excellent, excellent question. All right. Let's also wrap up our discussion of data management plans, because in addition to putting things and sharing them online, you should also specify who is going to be in charge of each of these things. So who is going to create the digital objects? Who's going to actually share data with any other lab members or collaborators who the data needs to be shared with? Who's going to track, manage, curate your data or metadata? Who's actually going to click that Zenodo upload button that you just saw me do? And the purpose here is not to identify permanent and indefinite roles, but it is here for us to show the grants review board or the grant review team that we have thought through the use and the life cycle of our data from start to finish. And this also does include identifying who is actually going to do each of these things. Now, there are still some challenges when we want to make data open. Specifically, there's some challenges in archiving data. The DOI system is a great one. Is it going to be a forever solution that's going to still be in existence 1,000, 2,000 years from now? Probably not. But for right now, it is the best that we have. Additionally, finding data sets can be very hard. We'll talk more about searching for data sets and searching for results in a few minutes. Using data, especially when it's related or delegated by legal restrictions or by data volume, can also be tricky because sometimes you can't download data just from the internet. You'll need to travel to a specific facility to access their data centers or their data sets. And of course, changes to the status quo. Today, we talked about CSV, Parquet files, and JSON files. Who's to say that those file formats will still be in any common use 5 to 10 years from now? So there can be changes in the status quo that make our data format seem like an antiquated selection. So note that a lot of these ideas are ever evolving, and just right now, some of these tools and some of these methods that we've talked about are simply the best that we have at this time. So let's talk about a lot of those forms that I just filled out when I was creating my Zenodo entry. These are often going to be metadata forms. Metadata just meaning that these are data that describe what's in the data. They'll typically come in 3 different types. You'll have descriptive metadata, structural metadata, and administrative metadata. Where your descriptive metadata contains information about the context or content of your data, titles, authors, dates, keywords. Your structural metadata will describe the actual structure of the data, such as in this folder, you'll find these 3 files, and these 3 files contain X, Y, and Z. And these files, you'll find something else, so on and so forth. And finally, you will have administrative metadata, which describes the management and technical aspects of the data, what file formats were used, what's their size and location, who created them, when were they made, so on and so forth. You should always, always, always keep in mind that metadata is essential to the implementation of the FAIR principles. You can think a title to an article, that is metadata. And you can think that our FAIR principles stand for findable, accessible, interoperable, and reusable. So if you want something to be findable, well, the title is a great piece of metadata to include because it's also going to pick up things like keywords. You can also think that metadata is going to help with the accessibility because you'll disclose typically the license in your metadata. So that's going to help with accessibility as well as interoperability and even reusability. So metadata overall is essential to the implementation of our FAIR principles. And even if you don't know it yet, you have already been using metadata in your publications. Like I just shared, the title is a very valid piece of metadata. Same with the publication date, same with the journal that it was published through, as well as the authors. Those are all pieces of metadata that are appended or added to the actual body of the article, which we can view as being the quote data itself. So let's talk about discovering open data. You can sure use Zenodo to upload your data, but you can also use Zenodo to search for data. And so we'll come back to that slide in just a moment, but if I go to zenodo.org, you'll see that I also have the ability to search records here. So if I want to search for weather data in California, I can search for weather California, and I can see what comes up. Of course, there's going to be a mix of all different kinds of media. So I'll come down here and I'll select the filter for data sets. I can also select the filter for open because I only want open data sets that I'm free to actually use. And then we can start scrolling through here to see if any of these data sets are going to meet my criteria. Now, there's going to be a few very important things that you should keep in mind when you are trying to find these data sets. I'm going to use another search provider. Let's use one that you all might be familiar with called Kaggle. Now, I would not recommend that you use Kaggle for academic purposes, but I want to show you why. If I search for that same term, weather for California, maybe I'll even do like historical for like past weather, and I want only data sets, not notebooks. So we can see here that there's 3 data sets at least matching this query, so maybe I'll just search for California weather, and then of course we'll filter by data sets again. California avocado production, that could be loosely related to weather. Let's try this one, California weather 2019. Now, I found a data set that I think I want to use, but now I have to go through and I have to make sense of the metadata that is also assigned to see if legally can I use this. So what I'm looking for here is I'm going to be looking for something I can cite. Is there a DOI? I'm going to be looking for what is the license? Does the license permit me to reuse this? And also, whenever you're searching for data, you should always be looking out for has this data been modified? Did this data come from another source? Because typically, if you find a data set and it actually originated from another source, it's probably in your best interest to go find that original source of that data and download it or use it from there. And that way you don't have any issues with over licensing or anything like that. So here I can see that there is absolutely no description of this data set. So although the title is California Weather 2019, they could be lying. I have no idea what's in this data set. There's no description. Is it like temperature? Is it rainfall? Is it precipitation? I have no clue here. So there's no metadata in terms of a description. I'll see on the right-hand side that there is no license attributed. And right here in the real world, this would stop my search for data completely. I would know that I cannot use this data set, and I probably should not use this data set for anything academically related. But we'll just continue on with this example here. We can see in the data set viewer, which is a very common feature of many of these services, you'll see that there is a source column or a year column, the month, the day, the hour, even down to the minute. So this is pretty high fidelity weather data. You can see what the temperature is. That's pretty interesting that the temperature in California was negative 11 degrees Fahrenheit, Celsius, probably Fahrenheit, but that's a guess. And so this is even just a broader sign that this data is fairly poor quality. I don't know what the units are for these temperatures here. And we can go on and go forth and we can continue dissecting this data set, but I think it's become pretty clear that we should not use this. Even if we could cite it, I probably would not touch this data set with a stick. So that is our exploration of a data set here on Kaggle. It's a good way to get started and see some data sets, but it's probably not the search engine I would use. Personally, one that I like is going to be the dataset search.research.google.com, which is a link on the slide, and we will be sharing the slides with you at the end of today. So to have a link to the dataset search.research.google.com, very handy. But this, if I search for weather California, instead of having a bunch of re-uploaded data sets, it's going to point me towards very official data sources for these types of data sets. So if I want daily weather records, I may still want to check out the NOAA. So for our generalist repositories for finding data sets, you can search through Zenodo, you can search through Mendeley Data, Figshare, Dryad, so on and so forth. You can also search through Kaggle. I wouldn't really recommend that one though, but you can also use Google's dataset search tool as well. So these are data and publication search portals. If you want to find some data sets, we have those search portals I just listed. Those are the generic ones, meaning you can find data of any type there. We'll also have domain-specific data set search portals. If you're specifically trying to find something for Earth data or geophysical data sets, well, you can check out NASA's Earth data. If you want to find something related to climate data, you can check out the NOAA climate data. Same with national and international data sets. You can, if you want to find out census or population level information or statistics, you can use the US federal data, the EU data portal, the WHO, so on and so forth. A lot of governments do publish or share some summary statistics on their populations for broader analysis. Now, if you're searching for publications, where you're searching for articles to read, well, then you have your generic engines and you have your domain-specific search engines as well. Probably the most well-known generic search engine for publications is going to be Google Scholar, or even ResearchGate, or even Open Knowledge Map, which I would highly check out if you haven't yet, because it gives you a very nice visual interface to cluster semantically related articles and shows you, lets you very easily find semantically related articles as well, as opposed to solely relying on text similarity. You also have domain-specific publication search portals, so you can look through specific journals, or you can go to NASA PubSpace, so on and so forth, if you want to find a publication related to a specific field. Now, a question has come up about whether I would personally recommend you use Zenodo or Mendeley. I do not have any recommendation as one to go over. I will say that personally, I am more familiar with Zenodo, and also I know that Zenodo is financially sponsored by CERN, whereas Mendeley is owned and operated by a large Elsevier, which is a very large for-profit publisher. So if that sways your opinion, then that can sway your opinion. If it doesn't, I would say they both will allow you to upload data sets, and they will also provide to you DOIs in return. So they do provide a lot of the same functionality. We have a brief discussion of data use and data licenses, because data licenses are slightly different than our software licenses that we have seen thus far. Specifically, our software licenses will have stipulations and limitations as to the source code of the thing that you are sharing. Our data and other digital content licenses, we're probably going to be reaching for something called Creative Commons licenses. And I will say that the Creative Commons licenses, the site that you can find is very, very helpful in order to figure out what each of these licenses is and when you should use them or when you should apply them. And the very nice thing about the Creative Commons licenses is they will have an international legally binding vocabulary. So you'll know that no matter where you are in the world, you will have these same types of protections as you would in your own home country. And so when it comes to choosing a Creative Commons licenses, they will come in just a handful of flavors. You'll have your Creative Commons BY clause license, and this just means that if anybody wants to use your content, they can reuse, they can redistribute it, they can change it, they can adapt it, and they can build upon it, but they have to cite you. They have to give you an attribution and say, the original works came from, here's insert citation here. So that's the BY clause. You'll also see a share alike, or an SA clause. You'll notice that this is a combination of two clauses. We have the BY clause and we have the SA clause here. The BY clause is the same thing. If you use whatever this license is attributed to, you have to cite me. If a share alike clause is also in existence, then whoever is using this, you have to use the same license I did. With the previous one, they could take my content and they could re-release it. They can change the license to whatever that individual prefers. But with the share alike clause, you have to reuse the same licenses that I used. Then there's going to be a non-commercial clause here. So this is a BY accompanied with a NC, or a non-commercial, meaning that you can do whatever you want with the data or with the digital content that I've uploaded or created here. You have to cite me, and you cannot use it to make a profit or for a commercial purpose. Academic research is perfectly great. Personal or private use, perfectly great, but you cannot go ahead and make money off of it. That's the non-commercial clause there. And you'll see that all of these licenses, you can kind of mix and match a lot of these clauses. So this is just a combination of you have to cite me, can't use it for commercial purposes, and you have to reuse the same exact license here. And finally, there's going to be an ND clause. This is going to be a no derivatives, meaning I'm limiting what you can do if you reuse this digital content. You can use it, however, you cannot redistribute it, you cannot alter it and then reshare it. You cannot create derivatives of the content that I have created here. So that's going to be our ND, or no derivatives or adaptations clause there. And that's pretty much all of the Creative Commons licenses. The last one is going to be CC0, which is their public domain dedication, just meaning that you're kind of relinquishing any control over this digital content that you have created. Anyone can download it, do whatever they want with it, make a profit off of it. You're just saying, here's my work, here's the license for it. You can go crazy, do whatever you want. And remember, the Creative Commons licenses will typically be used for data sets or other digital content. Things like the BSD3 clause or the MIT license, the things that we saw on choosealicense.com, these are going to be used primarily for software because they have clauses specifically about what you can and can't do with the source code of a project. And of course, if your project isn't software on Choose a License, well, this will actually show you and direct you towards some of those Creative Commons licenses there. I will say, if you have a mix of both software and data in a single repository, you can actually license the data under a Creative Commons clause, and you can actually license the source code under a different type of license. So you can have multiple licenses within a single repository there. So that is the long and short of the unique aspect of data and data licenses. They are just simply a different set of licenses that we will reach for. And at the end of the day, remember, a license is just a legal document that tells you what you can and cannot do with a data set, and if there are any stipulations that you need to abide by if you are going to use a data set or software. If there is no license, you cannot use the digital media that you are trying to use. And that is really the shortest and most condensed way that I can articulate to you the importance of licenses. They are legal protections and legal rules that you must follow if you're going to be using some digital content. So let's talk about a little bit about results before we wrap up and go for our very final quiz. Our depiction of what a scientific result has significantly changed. Our scientific results used to be very small, brief letters that were bound in a physical book, and then later on once we got the printing press, those books could then be productionized or they could be copied, and you would send out journals as close to the 1940s where we saw, or printing press way earlier than that, but we started creating commercialized journals. And now we're sending out issues and distributions of all of these bound physical entries of scientific research. And of course, once this became commercialized, then there was an exchange of money. So you would pay some publisher some amount of dollars per month, and they would send you back an issue every single, maybe quarter, every single month, depending on their release cycle. Well, nowadays, there's been a fairly large transition in how we think about how these scientific results should be shared. And there is the very famous open access movement. The open access movement started in the late 2000s, early 2010s. And the idea is that, well, scientific knowledge shouldn't exist behind just a paywall and shouldn't only be accessible to the ivory towers of the academic elite. Scientific results should be freely accessible to the general public here. And that is the heart of the open access movement. However, there is an issue. And the issue is that if I want to be able to share my data, share my scientific article, share my code, well, these all have to exist somewhere. And just having them exist online is great, but online hosting, you have to pay for server costs. So who's going to pay for that physical space or that computer space to host the servers, so on and so forth? Is it going to be the publisher? Is it going to be you and me? Well, this leads to a bit of a problem because by saying that knowledge should be available to all, we also need funding sources in place to make sure that that knowledge is accessible by all. And so we have more than just a publication to worry about. We're not just uploading PDFs. We are likely going to be uploading and sharing data proposals, data management plans, analytical code, notebooks, data, so on and so forth. And so we have to come up with a way where we can put these digital objects to live. They can live forever, and there has to be a funding source in place to make sure that these digital objects continue to live here. And so this all falls into our current publishing paradigm. But before I talk about our current publishing paradigm, let's talk very briefly about use, make, and share. And I think once I explain this, it'll be very obvious. If you want to perform an experiment, you should always check to see if a data set that is relevant to your experiment already exists. You should use something if it already exists. Now, if that data set doesn't exist, then you'll have to go out and make one. You'll have to collect the data. And if you're going to go through all of the effort of collecting that data and making a data set, you should absolutely then turn around and share that data and share that data set. And when you are sharing, make sure that you have a valid DOI, because that's going to ensure the permanent storage and the permanent linkage of that digital content or of that data set that you just collected. And so it's important. Don't go reinvent the wheel. But if you do have to make something, make sure that you share it so that other people don't have to go and reinvent the wheel or redo the same data collection that you have done, and they can start with the data set or the code that you have written, so on and so forth. Now, to wrap things up, we have our routes for open access publishing. As we talked about, open access is very important in today's publishing era. However, it has an issue where we have to figure out, well, who's paying for what? And so we have a couple of different routes here. If you follow the train, we're going to be starting with the gold line here. So the gold line takes a very quick trip right past what's called a preprint server. Preprint server is where you can drop off a copy of your article for free. Typically, you will do this so that you don't have to go through a formal peer review process, but you can say, hey, I have this article, it's time-stamped with this timestamp, here's my name on it, here's the title. And then you'll typically go through the formal peer review and publication process where you submit to a journal, they either accept or reject you, or reviewer number 2 absolutely tears apart your paper, but you still get to revise and resubmit so you can still make edits and then continue on with your publication process. Now, the tricky part here is that as the author for the gold open access line, you will typically pay what's called an article processing charge to a journal if you want your work to be open access. Open access means that anybody who comes to this article that you are publishing has access to it for free. And so the journal is just making you pay for anyone in the general public to access that for free in perpetuity. The issue with these article processing charges is that they can be incredibly expensive, usually around $2,000. I will say I just checked in on Nature's Gold Open Access plan. It's $10,000 to ensure the continued access of your PDF for free to the general public. And so these costs are incredibly expensive, so along comes the Diamond Open Access Publishing line. You can see that the Diamond line on this diagram follows the exact same path as the Gold line. The only difference is that for the Diamond line, you are either already have funding set aside to pay that open access charge or that article processing charge, or the journal that you are applying to will actually already pay for or receive separate funding from another institute in order to ensure that every publication that comes through is open access. And if you are curious about, well, what journals or what publishers are doing this type of Diamond open access where you as an author do not have to pay the money, I would encourage you to check out the link in the chat. That is the doaj.org. You can find it's the directory of open access journals, so you can find ways to make your work open access, and it will be free to you. Lastly, we have the green line, which is the line where you go through the act of uploading to just a preprint server, you skip the formal peer review and the formal publication process, and then you self-archive, you upload your code and relevant data to the something like Zenodo. And at this point, you don't need to pay anyone any money. You're only using free services. However, there's a little bit of skepticism involved here because not everyone is a fan of skipping that formal peer review process, and they're a little bit more skeptical about the quality of the papers that come through because you can't trust it at face value at the very least. So you'll have to have some domain expertise in order to assess whether or not you should trust a given paper that you find on a preprint server. We have seen 5 separate topics. We started with the purpose of open science, and we talked about ways that we can make our work more reproducible, how we can communicate data better, and we wrapped up today with our discussion of both open data and open results, seeing a number of different tools and workflows that we can use to make our work more transparent, more citable, and more accessible.